Hi, Algebra 2. If you were absent today, these are the day 10 notes over function operations part 2. We're going to multiply and write composition of functions. All right, so we decided to teach multiply and composition of functions on the same day to help you to not get them confused. They have different symbols. So if you look right here, this is what multiply looks like. It's like a little tiny dot. And then the symbol for composition of functions is this open circle. So we want to make sure that we look closely at our problems and see what kind of problem that we're looking at. So first, let's start with multiply. So function notation, multiplying functions can be written like this. It can be written as f of x, and this means times g of x, or it can be written like this, with the f and the g in the first set of parentheses. And this means the same thing, f of x times g of x. So our first step is that we're going to multiply in a box. So let's look at an example. The we do says f of x times h of x. So let's look at what we're multiplying here. We've got f of x, which is going to be negative 2x squared plus x minus 1. And we're going to be multiplying that by h of x, which is negative x minus 1. So I have two terms that I'm multiplying by three terms. So I like to multiply in a box. And so I'm going to go ahead and I'm going to draw a rectangle. So I can multiply two terms by three terms. And then I'm going to write my three terms across the top, negative 2x to the second power plus x minus 1. And then my h of x, my two terms, I'm going to write on the left-hand side, x minus 1. So now I'm going to multiply by following this top term and then over to the left with this term. I'm multiplying negative 2x squared times x. And so I could think of it as 1x. So I'm multiplying the negative 2 times 1, which makes negative 2. And then let's talk just a second about the ending here. If I have x squared and I'm multiplying it by x, over here on the left-hand column, you'll see there's a little box. It says we can review exponent rules. So one thing that we want to think of is that x to the power of 1 is equal to x. So if you see a single x, that means it's power of 1. And if I have two same bases with exponents and I'm multiplying, what I want to do is I want to add their exponents. So it's like x to the power of m plus n on that little rule. Okay, so we need to remember that when we multiply, our endings are going to change. So let's make a little note up here. Where we're multiplying, let's see here, I'll write it right here. We multiply the coefficients, or the numbers that are in the front, and we add the exponents. So when we multiply, the endings are going to change. It's not like combining like terms where we keep the same ending. So when we multiply the coefficients, we add the exponents. So this is x times x is x squared times another x, because I have that single x, makes this x to the third. Okay, so we're going to keep multiplying. I have positive 1x times positive 1x, so 1 times 1 is 1, and x times x is x to the second power. So I have two x's, so x to the second power. In the last square, 1x times negative 1 gives me negative 1, and I have that 1x. So now I'm going to start multiplying with the negative 1. So negative 1 times negative 2x squared. Negative 2 times negative 1 is a positive 2. And then I have my x squared on the end. And then my positive 1x times negative 1 makes negative 1x. And then negative 1 times negative 1 is positive 1. So I've multiplied, and what I multiplied is in the box. So the last step I want to do is combine my like terms after I've multiplied. So when you combine like terms, you're going to add the coefficients. And keep, I'm running out of room, the same ending. So this isn't going to change the ending. I'm adding like terms. So one of the reasons I kind of like multiplying in a box is it kind of helps me check my work, because on the diagonal here, I should have terms that have a like ending. So I have two terms that end in x squared, 2x squared and 1x squared. And then on this diagonal, I have two terms that end in x, negative 1x and negative 1x. And then I have just one term that ends in x to the third, the negative 2x to the third, and then the constant, or 1. So when I write my list, I'm going to combine my like terms as I go. So I have in my answer negative 2x to the third power. Now I'm going to add my x squareds. So I have 2 plus 1 makes 3 x squareds. I keep the ending the same. Negative 1 plus another negative 1 x makes negative 2 x. And then I just have my constant on the end. So this would be my answer when I'm multiplying. So next we have a you-do. This question is a little different. It kind of reminds me of just kind of an interesting test-styled question. It says the expression below is equal to j of x times h of x when j of x equals 3x plus 2 and h of x equals x minus 1. So here's the expression that they're giving us, that they're telling us is the answer to that multiplication problem, right? So they're saying that j of x times h of x is equal to that expression. And then it says, what is the value of k? So they want to know what number would be right here, the coefficient of the x term in our answer. So the way we want to answer that is we want to multiply j of x by h of x and see what we get. So let's look at j of x, which is its two terms. It's 3x plus 2. And then I've got my h of x, which is x minus 1. And so they're both two terms. 3x and 2 is two terms. X minus 1 is two terms. So let's make a box. So I just need a box with 4 squares. And then I'm going to write one of the equations on the top. And it really doesn't matter which one. Maybe I'll put this one on this side. 3x plus 2 is my one of them. And the other one is x minus 1. Excuse me. So then we're going to multiply in the box. So I can think of this as being 1x. So 3x times 1x. 3 times 1 is 3. X times x is x to the second power. In this box, negative 1 times 3 is negative 3. And then I have that single x. 1x times 2 is going to be 2x. And then I have negative 1 times positive 2, which is negative 2. And then I'm going to look in my box for my terms that should be like terms on the diagonal. And then I'm going to write my answer. So the first thing I have is this 3x squared term. And then I'm going to combine my terms that end in x. So negative 3x plus 2x makes negative 1x. And then I have my negative 2, my constant. So I write my answer in descending order by degree. So when I look back at my question, what is k? I can tell, okay, I've got 3x squared here. These match. That's right. I've got negative 2. That's right. So they're asking me, because it has the k next to the x, just for the number this number here that is in front of the x. So they're asking me for -1. So k would be equal to -1. All right, so that is kind of a review of multiplying. Always make sure you look in the middle to see if there, what kind of problem is this? Because yesterday we did add, subtract. So don't just immediately multiply everything, just check in the middle. And so it has that little dot, which means multiply. So the next thing we're going to look at is composition of functions. So there is a little note over here about composition of functions. This is the symbol. So again, when you see that open looking circle, and what it tells us we're going to do is we're going to replace the x in f of x with g of x. So essentially we're taking the inside equation and we're plugging it into the other equation as x. One important thing to note, because once in a while when you see some of those true-false questions about inverses, this could be something that they list. If I plug the inverse of x into f of x, they're going to simplify it'll simplify to equal x. And the opposite is true. If I plug f of x into the inverse of x, it's going to simplify to equal x. So that's a fact about inverses that is very, very important to remember, because sometimes they'll list that in true-false questions, that they simplify to equal x. All right, so we're going to look at some composition of functions here at the bottom. So they're giving us 4 different functions. For number 1, we're going to take k of x. Here's my k of x. It's 4x minus 2. And we are going to plug it in to f of x. So here's my f of x, right? And so I'm looking at f of x, and I'm going to put k of x right here for x. So it's like I'm plugging it in right here. So I'm writing f of x, but instead of x, I'm going to use 4x minus 2. Sometimes it helps people to write out that 4x minus 2 and then just kind of build around it. So see if that can help you. So instead of x, I have 4x minus 2, and in front of it, I have a 2 that's multiplied, and in the back of it, I have plus 7. So now we're going to distribute to simplify. 2 times 4x is 8x. 2 times -2 is -4. And then I have my plus 7 on the end, because I'm done multiplying, so I just add that 7. And I'm going to combine my like terms, and then my answer would be 8x plus 3. So that would be my simplified answer. And then looking at my simplified answer, it's not just a single x. So I could say that f of x and k of x are not inverses because they do not simplify to x. All right, let's look at the next one. So my next one, I'm plugging in h of x into p of x. Let me see if I have a couple different colors. And sometimes the colors help people. It's up to you, but it might help you kind of visualize it more. So I'm taking this inside function h of x, which is x minus 2, and it's going to become the x in p of x, the outside function. So I'm putting it right here is where I'm putting that x minus 2 in my p of x. And so I'm going to put a squared after it and a plus 5. Okay, so let's go ahead and start with writing what x is. Our new x is x minus 2. And then after it, I have to finish p of x, so I have a squared and then a plus 5. So now we're going to set it up. We're going to simplify it. So x minus 2 squared means x minus 2 multiplied by another x minus 2, and then plus 5 on the end. So you can multiply that in a box, or you can just use either double distributor foil. Maybe I'll multiply it in a box and show you what I mean. So I'm going to be multiplying x minus 2 times x minus 2. And so x times x, or 1x times 1x is 1x squared. Here I'm going to get negative 2x. X times negative 2 is negative 2x. And in the bottom right, negative 2 times negative 2 is positive 4. So when I multiply in a square, I'm going to combine these like terms. And so the part of my equation that is, or the part of my expression that is x minus 2 times x minus 2 is going to be x squared minus 4x, because I'm going to combine these negative 2x's. And then on the end, plus 4. And then I still have my plus 5. So my last step would be just to combine these like terms. And my answer would be x squared minus 4x plus 9. And that's the simplified version. Okay, so if you want to try to set one up, you can pause the video and then check your answer and try to do the U-do. So I've set up my equation and I'm plugging in this whole p of x, that whole expression, x squared plus 5 into k of x for x, and then I'm going to simplify it. So when I simplify, 4 times x squared is 4x squared, 4 times 5 is 20, and then my minus 2 on the end. Excuse me. So then I could combine the 20 and the minus 2 would be 4x squared plus 18, and that would be my answer. And again, those aren't inverses because they do not reduce to make x. So if you plug a function into another function and they reduce or simplify to make x, that means they're inverses. Your homework tonight, let me show it to you because it had a couple of typos on it, and I apologize for that. So it matches your notes. It has like a little megaphone and a pom-pom on it. On number 5, so you're going to find that when you work number 5, that your answer will not be written in the form ax squared plus bx plus c. It will only be in the form bx plus c. It'll be a term that ends in x and a constant. And so you can still answer the question, what is the value of b? But I don't want that to throw you off because there will not be an ax squared term. And then on number 7, it talks about multiplying f of x and g of x, and it gives you what it equals, and it asks you for k. But the exponent on the first term says 3x squared, and that should be 3x to the third power. So I don't want that to throw you off when you're multiplying. All right, come and see me if you have any questions.